Okay, so if you're looking at points on a number line that you want to find the distance between them, first off, let's think of these points on a number line. So go ahead and draw your number line. Make sure you don't have every number out there, but make sure you include at least 5 and 12. So I'm going to put a spot at 5 for A and 12 is B. If I want to find the distance between those, since it's on a number line, I could count. But what if we have numbers that are too large? They don't fit on a number line. Then what you want to do is subtract the two, so either B minus A or A minus B, and then you do the absolute value. So for this, if I did A minus B, that'd be 5 minus 12. I'm going to do the absolute value of that. 5 minus 12 is negative 7. So absolute value, which if you don't remember, is just the distance from 0. So negative 7 is 7 units from 0. So my distance between A and B is 7. Again, you could have done B minus A. Absolute value of 12 minus 5 becomes the absolute value of 7, which is 7. It does not matter which one you do. You do not have to do both, but one of them will give you the correct distance. Make sure you do absolute value, though. Let me try one more with you. So absolute value of negative 5 minus 1 would be the absolute value of negative 6, which is 6. And if we look at our number line, if I have negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, here is D, here is C. If you count that distance, they are 6 spaces away. Go ahead, I want you to do on your own, so pause this in a minute, and do 3 and 4. I put the work on here for you, but on 3, when you subtract them and then do absolute value, you get a distance of 13. On 4, when you subtract and do absolute value, you get a distance of 106. Next thing we're going to look at finding midpoint when we're looking at a number line. So that is the formula for it, A plus B divided by 2. We are going to use that formula to find the coordinates of the midpoint. I do want to show you first without the formula. If I'm looking at my number line again, so let me make sure I get all of these points on here. So A is at 5, B is at 12. Midpoint just means the point that's in the middle. So I'm going to kind of count in, let's count in 3 spaces there, 1, 2, 3 spaces, and then it should be right in the middle of that, which would be at 8, 5. That's great if I'm on a number line and I can count, and I'm using whole numbers. But if my numbers are too big to be on a number line, or I have fractions and decimals involved, I need a formula to follow. So my formula says add the 2 and then divide by 2. It's just like finding the average of 2 points. 5 plus 12 is 17, divided by 2 would be 8.5. Okay, and I can do that again for C and D. I'm going to do negative 5 plus 1 divided by 2. Negative 5 plus 1 is negative 4. Divided by 2 is negative 2. If you're looking at your number line, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. Here's C. Here's D. Counting in, so 1, 2 that way, 1, 2. Count another one in each direction. I do land right there at negative 2. Go ahead and try 3 and 4. They're the same points as before. On your own, pause this, and then you can come back and check your answers. Okay, 3 I added and divided by 2, and I got the midpoint for 3 to be negative 11.5. On 4, again, I added and divided by 2, so I got the midpoint for G and H to be at 18. Right, next, we're going to use what we did in the warm-up for Pythagorean theorem to try to find distance. We are going to be using a coordinate plane, so go ahead and draw your x and y axes. Alright, I have my x and y axes. The 2 points we're going to use are A and B. A is at negative 4, negative 3, so negative 4 for the x, negative 3 for the y, and then B is at negative 1, 2. I want to find this distance here. Right, if they were going straight across, you could just count the boxes kind of like you would on a number line, but since it's going diagonal, you cannot do that. So what we are going to do is kind of draw in to make this into a right triangle. because since this is going straight across, I can count this side as being 1, 2, 3 units long. I can count this side as being 1, 2, 3, 4, 5 units long. And then I can use that Pythagorean theorem to find that distance. Now this is only helpful if it's slanted. If the points you're trying to find are straight across from each other, you can just count the blocks. But when they're diagonal, you do need to draw on your triangle. C is the hypotenuse, so C will be the side we're trying to find for now. A and B are just the other two sides. So when I do that, 3 squared is 9, 5 squared is 25. 9 plus 25 is 34. When you do the square root, which remember is this button here on your calculator, of 34, you get about 5.8 roughly. So that length there is about 5.8 units long. For tonight, make sure you finish this worksheet and are doing the problems in the book, and you're welcome to put those problems just on the back of your worksheet.